Hello students, welcome to this lecture, one introduction to trigonometry and its applications. So in this lecture, we will discuss NCERT exemplars problem on this chapter. Okay, so let's get started. So in this question, if the length of the shadow of a tower is increasing, then the angle of elevation of the sun is also increasing. Okay, so let us see how to solve this problem. So basically, here we have given this statement and we have to check whether the statement is true or false. So that's to understand the fact of this question, here consider the following example. So if we take this example, a tower 2 times root 3 meter high casts a shadow 2 meter long on the ground, then the sun's elevation is 60 degree. Okay, so we can draw the figure. So here suppose we have a sun, okay, and here this makes an angle, a triangle ABC. So from this triangle ACB, here tan theta, this is equal to actually root theta, and we know tan 60 degree, this is equal to root uh, root 3. Okay, so tan theta is equal to tan 60 degree, and it implies tan theta is equal to 60 degree. Okay, so the value of theta is equal to 60 degree, and say is a same height of the tower cast a shadow 4 meter more from preceding. Okay, so then the sun's elevation is 30 degree. So in this triangle APV, here tan theta, this is equal to actually height by base. Okay, so tan theta is equal to AB by PB, and this is equal to AB divided by PC plus CB. Okay, and it implies tan theta is equal to 2 times root 3 divided by 4 plus 2. Okay, and this is equal to 2 times root 3 divided by 6, and it implies tan theta, this is equal to root 3 times root 3 divided by 3 times root 3. That is basically equal to 3 by 3 times root 3. Okay, so it implies tan theta, this is equal to 1 by root 3, and we know the value of tan 30 degree, this is equal to 1 by root 3. So it implies tan theta, this is equal to tan 30 degree, and it implies theta is equal to 30 degree. Okay, so therefore the angle theta, this is equal to 30 degree. Hence we can conclude from the above two examples that if the length of the shadow of a tower is increasing, then the angle of elevation of the sun is decreasing. But in our given statement, here we have given if the length of the shadow of a tower is increasing, then the angle of elevation of the sun is also increasing. But here we get if the length of the shadow of a tower is increasing, then the angle of elevation of the sun is decreasing. Okay, so the given statement is a false statement. Now let us move to next problem. So in next problem, here we have if a man standing on a platform uh, 3 meter above the surface of a lake observes a cloud and its reflection in the lake, then the angle of elevation of the cloud is equal to the angle of depression of its reflection. Okay, so let us check whether the given statement is true. Okay, so let us check here from this figure. So from this figure, we observe that a man standing on a platform at point P. Okay, so we can see this figure, and from this figure we can observe that the standing on a platform at point P and 3 meter above the surface of a lake, and also observe a cloud at point C. Okay, let the height of the cloud from the surface of the platform is height h. Okay, so here the height of the cloud from the surface of the platform is h, and angle of elevation of the cloud be theta 1. Now at some point P, a man observes a cloud reflection in the lake. At this time, the height of reflection of cloud in lake is h plus 3, because in lake platform height is also added to reflection of cloud. Okay, so angle of reflection is different in the lake from the angle of elevation of the cloud above the surface of a lake. So from this figure here in this triangle MPC, angle of elevation is theta 1. Okay, so tan theta 1, this is equal to cm by pm. Okay, so this is cm by pm, that is actually tan theta 1, and here cm is equal to h meter, so tan theta 1, this is equal to h by pm, and it implies tan theta 1 by h, this is equal to 1 by pm. I am naming this equation number 2. And now from this triangle CPM, so from this triangle here the angle of depression is theta 2. Okay, so here tan theta 2, this is equal to cm by pm, and here this is equal to OC by f, and it implies tan theta 2 by h plus 3, this is equal to 1 by pm, since cm this is equal to h plus 3. Okay, so therefore we get these two equation, and now comparing these two equation, then we get tan theta 1 by h, this is equal to tan theta 2 by h plus 3. Okay, so hence tan theta 1 by h equal to tan theta 2 by h plus 3, and the statement false. We know that if P is a point above the lake at a distance d, then the reflection of the point in the lake would be at the same distance d. Okay, also the angle of elevation and depression from the surface of the lake is same. So here the man is standing on a platform 3 meters above the surface. So its angle of elevation to the cloud and the angle of depression to the reflection of the cloud is not same. Okay, so therefore the given statement is a false statement. So if a man standing on a platform from 3 meters above the surface of a lake observes a cloud and its reflection in the lake, then the angle of elevation of the cloud is equal to the angle of depression of its reflection. This statement is a false statement, since the angle of elevation of the cloud is not equal to the angle of depression of its reflection. Okay, so now let us move to next problem. So in next problem, here we have the value of 2 sine theta can be a plus 1 by a, where a is a positive number and a does not equal to 1. Okay, so let us check this statement. So use the relation between arithmetic mean and geometric mean. So we know this relation, arithmetic mean is always greater than geometric mean. Okay, so here given a is a positive number and a does not equal to 1, then am greater than gm, it implies a plus 1 by a by 2, this is greater than square root of a times 1 by a, and it implies a plus 1 by a, this is greater than 2. Since am and gm of two numbers a and b are a plus b by 2 and square root of ab respectively, that is why we get this relation a plus 1 by a is greater than 2, and it implies 2 sine theta, this is greater than 2, and it implies sine theta, this is greater than half. Okay, so since 2 sine theta, this is equal to a plus 1 by a, and since we know sine theta always lies between -1 to 1, and sine theta is always greater than equal to -1 and less than equal to 1. Okay, so this is not possible, hence the value of 2 sine theta cannot be a plus 1 by a. Okay, so the given statement, the value of 2 sine theta can be a plus 1 by a, where a is a positive number and a does not equal to 1. This statement is a false statement. Okay, so now let us move to next problem. So in next problem, here we have cos theta, this is equal to a square plus b square divided by 2ab, where a and b are two distinct numbers such that ab is greater than 0. Okay, so let us check the statement. Here given a and b are two distinct numbers such that ab is greater than 0. So here we've also used the concept of am and gm. So we know the relation between arithmetic mean and geometric mean as am is greater than gm. Okay, since here am and gm of two numbers a and b are a plus b by 2 and square root of ab, so it implies a square plus b square by 2, this is greater than square root of a square into b square. Okay, and it implies a square plus b square, this is greater than 2ab, and it implies a square plus b square divided by 2ab. This is greater than 1. Since cos theta, this is equal to a square plus b square by 2ab, and we know cos theta always lies between -1 to 1. That means cos theta is always greater than equal to -1 and less than equal to 1. Okay, but here we get cos theta that is equal to a square plus b square by 2ab. This is greater than 1. So it implies cos theta is greater than 1, which is not possible. Okay, hence cos theta cannot be equal to a square plus b square by 2ab. So the given statement cos theta is equal to a square plus b square by 2ab, where a and b are two distinct numbers such that ab is greater than 0. This statement is a false statement. Okay, so let us move to next problem. So in next problem, here we have the angle of elevation of the top of a tower is 30 degree, and if the height of the tower is double, then the angle of elevation of its top will also be double. So let us check the statement. So let us check the given statement. So here first of all we see thinking process. Okay, so number one, firstly we find the relation between h and x by putting angle of elevation is 30 degree in case 1. Okay, and second, after that we take double height and taking angle of elevation is theta. Then now use the relation 1 and get the desired result. Okay, so case 1, here let height of the tower be h, and here bc this is equal to x meter. Okay, so in triangle abc, here tan 30 degree this is equal to ac by bc, that is equal to h by x. Okay, and it implies 1 by root 3 this is equal to h by x. So we get this relation h by x this is equal to 1 by root 3. And second case, by condition the height of the tower is double, that case here pr in this in pr this is equal to 2h, and from now triangle pqr, here tan theta this is equal to pr by qr, this is equal to 2x by x. Okay, and it implies tan theta this is equal to 2 by x into x by root 3, that implies tan theta is equal to 2 by root 3, that is equal to 1.15. So therefore theta is equal to tan inverse of 1.15, and this is always less than 60 degree. Okay, so it implies tan theta this is equal to 2 by x times x by root 3, and since h is equal to x by root 3 from this equation 1, okay, so we get this tan theta is equal to 2 by x times x by root 3, that is equal to 2 by root 3. Hence the required angle is not double. Okay, so here the statement, the angle of elevation of the top of a tower is 30 degree. If the height of the tower is double, then the angle of elevation of its top will also be double. But here we get the required angle is not double. Okay, so the given statement is a false statement. Okay, so the given statement is a false statement. Now let us move to next problem. So in next problem, here we have, if the height of a tower and the distance of a point of observation from its foot both are increased by 10, then the angle of elevation of its top remains unchanged. Okay, so let us see here. In case 1, here we first of all let height of a tower be h. Okay, and distance of the point of observation from its foot is x. Okay, so from this triangle abc, here the angle of elevation is theta 1 and height ac is h and the base bc is x. Okay, so from this triangle abc, here tan theta 1 this is equal to ac by bc, and this is equal to h by x. Okay, so from this equation tan theta 1 is equal to h by x, it implies theta 1 this is equal to tan inverse of h by x, and naming this equation number 1. And now let us move to case 2. So in case 2, now the height of a tower increase by 10. Okay, so now the height is equal to h plus h times 10 by 100, that is equal to 11h by 10. Okay, and the distance of point of observation from its foot this is equal to x plus 10 of x, that is x plus x times 10 by 100, that is equal to 11x by 10 also. Okay, so here the height of a tower increased by 10, this is equal to 11h by 10, and the distance of the point of observation from its foot, this is equal to also 11x by 10. Okay, now from this triangle PQR, here the angle of elevation is theta 2. Okay, so now tan theta 2, this is equal to PR by QR, and here the PR is equal to 2, PR is equal to 11h by 10, and QR is equal to 11x by 10. Okay, so it implies tan theta 2, this is equal to 11h by 10 divided by 11x by 10, and it implies tan theta 2, this is equal to h by x, and it implies theta 2, this is equal to tan inverse h by x, and naming this equation number 2. Okay, so now from equation 1 and 2, here it implies theta 1, this is equal to theta 2. Okay, hence the required angle of elevation of its top remains unchanged. So therefore if the height of a tower and the distance of the point of observation from its foot both are increased by 10, then the angle of elevation of its top remain unchanged. Okay, so the given statement in question number 12, this statement is a true statement. Okay, so now let us move to next section. So in next section, here we will discuss short answer types questions. Okay, so in first question, here we have to prove the following. Here we have to prove the following questions from 1 to 7. Okay, so let us prove first question. So in first question, here we have, in left hand side, sin theta by 1 plus cos theta plus 1 minus 1 plus cos theta by sin theta, this is equal to 2 cosec theta. Okay, so this is given to us, so we need to prove left hand side, this is equal to right hand side. Okay, so here in this question, left hand side, this is equal to sin theta by 1 plus cos theta plus 1 plus cos theta by sin theta. Okay, and now if we simplify it, then we will get this is equal to sin square theta plus 1 plus cos theta whole square divided by sin theta times 1 plus cos theta. Okay, so since we know this formula, a plus b whole square, this is equal to a square plus b square plus 2ab. Okay, so if we now use this identity, with the algebraic identity, a plus b whole square is equal to a square plus b square plus 2ab, then we'll get this is equal to sin square theta plus 1 plus cos square theta plus 2 cos theta divided by sin theta into 1 plus cos theta. Okay, and we know the trigonometric identity, that is sin square theta plus cos square theta, this is equal to 1. Okay, so now if we put the value of sin square theta plus cos square theta is equal to 1, then we'll get this is equal to 1 plus 1 plus 2 cos theta divided by sin theta into 1 plus cos theta. Okay, and this is equal to 2 times 1 plus cos theta divided by sin theta times 1 plus cos theta. So here in numerator we have 2 times 1 plus cos theta, and in denominator we have sin theta into 1 plus cos theta. Okay, so here the common term in numerator and denominator is 1 plus cos theta. So 1 plus cos theta, 1 plus cos theta will cancel, and we'll get this is equal to 2y sin theta. Okay, so in left hand side we get 2y sin theta, and this is actually equal to 2 times cosec theta, since we know cosec theta, this is equal to 1 by sin theta. Okay, so 2y sin theta, this is equal to 2 cosec theta, and this is actually our right hand side. Okay, so here left hand side is equal to right hand side, hence proved. Okay, so now let us move to next problem. So in next problem, here we have tan, in left hand side we have tan a by 1 plus sec a minus tan a by 1 minus sec a, and in right hand side we have 2 cosec a. Okay, so to prove that tan a by 1 plus sec a minus tan a by 1 minus sec a, this is equal to 2 times cosec a. Okay, so let us prove this problem. So here left hand side is equal to tan a by 1 plus sec a minus tan a by 1 minus sec a. Okay, and this is equal to tan a times 1 minus sec a minus 1 minus sec a. Okay, divided by 1 plus sec a into 1 minus sec a, and here this is equal to tan a times minus 2 sec a, since here plus 1 and minus 1 will cancel, and minus sec a, that is minus 2 sec a. Okay, and here in denominator 1 plus sec a into 1 minus sec a, this is equal to 1 minus sec square a. Since we know the identity a plus b times a minus b, this is equal to a square minus b square. Okay, so we get this is equal to 2 tan a times sec a divided by sec square a minus 1. Okay, and it is equal to 2 tan a into sec a divided by tan square a. Since we know the trigonometric identity sec square a minus tan square a, this is equal to 1. Okay, and since we know sec theta, this is equal to 1 by cos theta, and tan theta, this is equal to sin theta by cos theta. Okay, so we can now use this formula and we'll get this is equal to 2 sec a divided by tan a, and this is equal to 2 by sin a times 2 by sin a, and this is equal to 2 cosec a. Since we know cosec theta, this is equal to 1 by sin theta, that is why 2 by sin a, this is equal to 2 cosec a, and this is actually our right hand side. So here we get left hand side, this is equal to right hand side. Okay, hence proof second one. So now let us move to next problem. So in next problem, here we have the value of tan a, that is equal to 3 by 4. Then we need to see, we need to show sin a into cos a, this is equal to 12 by 25. Okay, so let us solve this problem. So we know that tan theta, this is equal to actually perpendicular by base. Okay, so now using Pythagoras theorem, get the values of hypotenuse, that is actually hypotenuse square is equal to base square plus perpendicular square, and then find the value of trigonometric ratios sin theta and cos theta and get the desired result. So here given that tan a, this is equal to 3 by 4, and we know tan a is equal to perpendicular by base. So here we can let perpendicular p, this is equal to 3k, and base b, this is equal to 4k. Okay, where k is any positive integer. So now by Pythagoras theorem, hypotenuse square, this is equal to perpendicular square plus base square. So here the perpendicular is 3k and base is equal to 4k. So hypotenuse square, this is equal to 3k square plus 4k square, that is equal to 9k square plus 16k square, that is equal to 25k square. Okay, so hypotenuse, this is equal to 5 times k. Okay, so hypotenuse is equal to 5 times k, and therefore sin a, this is equal to perpendicular divided by hypotenuse, and here the perpendicular is 3k and the height is 5k. Okay, so therefore sin a, this is equal to 3k by 5k, that is equal to 3 by 5. Okay, and cos a, that is equal to base by hypotenuse. So here the base is 4k and hypotenuse is 5k. Okay, so cos a, this is equal to 4k by 5k, that is equal to 4 by 5. Okay, so now sin a into cos a, this is equal to 3 by 5 into 4 by 5, that is equal to 12 by 25. So here we need to prove sin a into cos a, this is equal to 12 by 25, and hence proved. Okay, so now let us move to next problem. So in next problem, here we have to prove that sin alpha plus cos alpha times tan alpha plus cot alpha, this is equal to sec alpha plus cosec alpha. Okay, so here let us prove this problem. So in left hand side, we have sin alpha plus cos alpha times tan alpha plus cot alpha. Okay, so this is here we know this formula. Tan theta, this is equal to sin theta by cos theta, and cot theta, this is equal to cos theta by sin theta. Okay, so now we can write tan in terms of tan alpha we can write sin alpha by cos alpha, and cot alpha we can write cos alpha by sin alpha. So this is equal to sin alpha plus cos alpha times sin alpha by cos alpha plus cos alpha by sin alpha. Okay, and this is equal to sin alpha plus cos alpha times sin square alpha plus cos square alpha divided by sin alpha cos alpha. Okay, and since we know the identity sin square alpha plus cos square alpha, this is equal to 1. Okay, so this is equal to sin alpha plus cos alpha times 1 by sin alpha cos alpha. Okay, and now this is equal to actually 1 by cos alpha plus 1 by sin alpha, and this is equal to sec alpha plus cos alpha, and this is actually our right hand side. Okay, so here sine right hand side, left hand side, this is equal to right hand side, hence proved. And now let us move to next one. So in next problem, here we have to prove that root 3 plus 1 times 3 minus cot 30 degree, this is equal to tan cube 60 degree minus 2 sine 60 degree. Okay, so in this problem here, in right hand side we have tan cube 60 degree minus 2 sine 60 degree. Okay, so in right hand side is equal to tan cube 60 degree minus 2 sine 60 degree, and we know the value of tan 60 degree, that is root 3, and sine of 60 degree, this is equal to root 3 by 2. Okay, so now if we put the values of tan 60 degree is equal to root 3 and sine 60 degree, this is equal to root 3 by 2 in right hand side, then we'll get this is equal to root 3 cube minus 2 times root 3 by 2, that is equal to 3 times root 3 minus root 3, this is equal to 2 times root 3. Okay, and left hand side, this is equal to root 3 plus 1 times 3 minus cot 30 degree, and we know the value of cot 30 degree, that is equal to root 3. Okay, so this is equal to root 3 plus 1 times 3 minus root 3. Okay, and now if we simplify it, then we'll get this is equal to 2 times root 3. Okay, so here left hand side, this is equal to right hand side, hence proved. And now let us move to next one. So in next question here, we have to prove that 1 plus cot square alpha by 1 plus cosec alpha, this is equal to cosec alpha. Okay, so let us prove this problem. So here left hand side, this is equal to 1 plus cot square alpha by 1 plus cosec alpha. Okay, and we know this formula, cot theta, this is equal to cos theta by sin theta, and we know cosec theta, this is equal to 1 by sin theta. Okay, so left hand side, this is equal to this, and this is equal to 1 plus cos square alpha by sin square alpha divided by 1 plus 1 by sin alpha. Okay, and now if we simplify it, then we'll get this is equal to 1 plus cos square alpha divided by sin alpha into 1 plus sin alpha, and this is equal to sin alpha into 1 plus sin alpha plus cos square alpha divided by sin alpha into 1 plus sin alpha. Okay, and this is equal to sin alpha plus sin square alpha plus cos square alpha divided by sin alpha times 1 plus sin alpha. And since we know sin square theta plus cos square theta, this is equal to 1. Okay, so here we can substitute the value of sin square alpha plus cos square alpha is equal to 1. Okay, then we'll get this is equal to sin alpha plus 1 divided by sin alpha into sin alpha plus 1. Okay, and here sin alpha plus 1 and sin alpha plus 1 will cancel in numerator and denominator, and then we'll get this is equal to 1 by sin alpha. Okay, and this is equal to cosec alpha, since we know that cosec theta is equal to 1 by sin theta. Okay, and this is our right hand side, so hence 1 plus cot square alpha by 1 plus cosec alpha, this is equal to cosec alpha. Okay, now let us move to next problem. So in next problem here we have to prove that tan theta plus tan 90 degree minus theta, this is equal to sec theta times sec of 90 degree minus theta. Okay, so let us prove this problem. So here in left hand side, here we have tan theta plus tan 90 degree minus theta. Okay, so we know this formula, tan 90 degree minus theta, this is equal to cot theta. Okay, so this is equal to tan theta plus cot theta, that is equal to sin theta by cos theta plus cos theta by sin theta, since tan theta is equal to sin theta by cos theta and cot theta is equal to cos theta by sin theta. Okay, and this is equal to sin square theta plus cos square theta divided by sin theta into cos theta, and we know this identity, sin square theta plus cos square theta is equal to 1, so therefore this is equal to 1 by sin theta into cos theta, and we know sin theta is equal to 1 by cosec theta, that means cosec theta is equal to 1 by sin theta, and we know sec theta is equal to 1 by cos theta, so therefore this is equal to sec theta into cosec theta. Okay, so it implies this is equal to sec theta into sec 90 degree minus theta. Since sec 90 degree minus theta, this is equal to cosec theta. So this is actually our right hand side. Okay, so here left hand side, this is equal to right hand side, hence proved. And now let us prove question number 9. So in question number 9, here we have here actually in question number 8, find the angle of elevation of the sun when the shadow of a pole h meter high is root 3 h meter long. Okay, so here the angle of elevation of the sun is theta. Okay, so this is our angle of elevation, angle theta. Okay, so here we given the pole, given height of the pole is h, and this in this triangle ABC here, mm, tan theta, this is equal to AB by BC. Okay, AC by BC, and this is equal to h by root 3h, and this implies tan theta, this is equal to 1 by root 3, and we know tan 30 degree, this is equal to 1 by root 3. So it implies theta is equal to 30 degree. So hence the angle of elevation of the sun is 30 degree. And now here we, if root 3 tan theta is equal to 1, then find the value of sin square theta minus cos square theta. Okay, so we have given root 3 tan theta is equal to 1. Okay, so here from this equation, it implies tan theta, this is equal to 1 by root 3, that is equal to tan 30 degree. Okay, and it implies theta is equal to 30 degree. So now sin square theta minus cos square theta, this is equal to sin square 30 degree minus cos square 30 degree, and we know the value of sin 30 degree is equal to 1 by 2 and cos 30 degree is equal to root 3 by 2. Okay, so this is equal to 1 by 2 square minus root 3 by 2 whole square, that is equal to 1 by 4 minus 3 by 4, that is equal to 1 minus 3 by 4, and this is equal to minus 2 by 4, and this is equal to minus 1 by 2. So therefore the value of sin square theta minus cos square theta, this is equal to minus 1 by 2. So this is all about this lecture. So thank you very much to all of you.